All right, wonderful. People, let's go ahead and get started. Today is half a day, so we're not going to run the entire normal length of the class period. So we'll just see how far we can get on this. So let's, for this one here, we're going back to Monday. So if you remember Monday, we stopped, we stopped on this slide right here, where we were plugging in the numbers for the functions. And in this case here, we are doing some of the same stuff, but I said that you didn't have to complete all of them. Just, you know, I think I made it extra credit, so you can go ahead and not do this, but I'm gonna go over it anyway. So that way we can take up our day time here. And it's a good opportunity to go back and finish this. And a lot of the lessons for this are pretty good. All right, so there you go. So I need the function p, and don't forget when it says p of x, that's just the name of the function. So it's just like this name, if the function's name was Pete or something. So I have to use that one, and then g of x, or wait, that's q, so that'd be q. I don't know any names that start with q. The only name I know that starts with q is Quaid, but I don't think that's really a very common name anymore. All right, so I set it up, plugged in -9/16 in for x, and I'm gonna cross cancel. So cross canceling is just like simplifying fractions, right? If I had 9/3, I could simplify that to 3/1. So you just kind of like imagine that the number is over or in the same fraction as the other one. So in this case, it would be 4/16. 4/16, I can divide both of those by 4. And you know, if you divide it by 2 or something else like that, then just divide it again. You know, there's no limit on how many times you can do this. So if you don't take it all the way down, you can simplify it again. And what that allows me to do is it allows me to reduce my fractions before multiplying them. So here I'm not multiplying my fractions. I'm sorry, I am multiplying my fractions, but I don't need to multiply the big number, right? Because if I had to multiply all of this, it would be a much bigger number and I'd have to spend more time simplifying it. So it's easier to just simplify before taking care of that. So in this case here, I have 1/2. And negative times negative will be positive. And 1 times 3 is my top number, so that'd be 3. And 1 times 4 is my bottom number. So that becomes 1/2 plus 3/4. Now, when you're adding fractions, you have to have the bottom number be the same, what we call common denominator. So with this here, I'm going to change the numbers on my first one. Now, this is something that is confusing to some people who don't work with fractions all that much. And that is, I need a number that means the same thing, but looks different. So if I were to punch into a calculator 1 divided by 2, I would get 0.5. If I had a calculator and punched in 2/4, I would still get 0.5. It is the same number, it just looks different. It means the same thing, but I need that bottom number to match, because now, if my bottom numbers match, that means my top numbers are counted by the same number, or you can think of it as they are the same size type of number. And I'm gonna go ahead and add those together, so I get 5/4. And this should be enough to write out my final answer. So p of -9/16. So again, the function p, when I input -9/16, is 1 1/4. Now you could also just put 5/4 in there, or use a calculator and you'd get 1.25. But I'm gonna go with mixed number. I like mixed numbers. They are very useful. You know, if you're going to go into like any kind of trade, you need to know your fractions. All right, next one, number 8, q at 5. So I'm going to plug in 5 into this equation. Yeah, this equation function here. So I am going to need to get into get a absolute value, 3 times 5 minus, and I have 5 to the third power here. Now I should put these in parentheses so that I don't mix any of those up. There you go. Now it looks a little bit more like 5. Now let's go ahead and start evaluating it. 3 times 5, okay, that's going to be 15. And there's still the absolute value. We haven't used that up yet. Minus, and for this one here, that minus is not included in the parenthesis. So we just go 5 to the third power. So it's 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. And now I have 15 minus 125. I'm going to reverse the roles and make it, okay, so let me back up. I know it's going to be negative. It's going to be negative because my negative is the bigger number. Now, when I say bigger, I don't mean greater, right? Because positive numbers are always greater than negative numbers. But when I say bigger, I mean the one that's further away from 0 on the number line. So the negative is a bigger number, and the 15 is a positive number, which is smaller. So I'm going to reverse the roles. So it's going to be 125 minus 15, which is 110. But again, it takes the sign of the larger number, the bigger number. And now I have pretty much this entire thing solved. So Q5. So when I input 5, and now I just got to use up my absolute value. So absolute value is going to make it positive. So positive 110. And there we go. All right, so let's go ahead and plug in -2. Now this one might be a bit of a tricky one. And I'll show you why in just in a second. So absolute value of 3 times -2 minus -2 to the third power. Now we're used to, like when we square a negative number, it becomes a positive number because negative times negative is positive. But we got to make sure we follow the order of operations very carefully in this case because there's a multiplication. This is times a negative and to the third power. Times a negative to the third power. So we always take care of the exponents before we multiply. So we got to do this one first. So 3 times -2 is -6. Now, I'm going to go ahead and just write the whole thing out here like that. So -2 times -2 times -2. So -2 times -2 is going to be +4 times -2. Now this minus comes down here, but inside of this parenthesis, I have 4 times -2, which is going to be -8. Leave that absolute value sign there. Now I have -6 minus -8. And remember, if you minus a negative number, if you take away a negative, it becomes positive. So -6 plus 8, -6 plus 8, and that would be 2. And it's already positive, so I don't need to change anything. The absolute value is going to keep it positive, not change it to a negative because it doesn't flip the sign. It only makes things positive. So there you go. When we put -2 into the function q, we get 2 as the output. That's the result. And again, with all these functions, they're just like machines. You put something in and you're supposed to get something back out. All right, now time for this one here. And again, I know these fraction ones are a little bit, they're confusing. Even when students are taking classes normally and they can ask me questions, it's still a bit of a, you know, can be frustrating or anything like that. Be a hassle. So that's why I made this one extra credit. All right, so again, cross cancel. So look at the top and bottoms of each ones and see if there's anything you can cancel, which in this case, it looks like I can cancel 3 and 18 because both of them can be divided by 3. 3 divided by 3 is 1, so I put 1 there, and 18 divided by 3 is 6, and I have no other numbers. Now, in a fraction, when your numbers become 1 on bottom, that just means it becomes a whole number. So we worked with the fraction one, so I'm going to go ahead and turn this one into a decimal. So half is going to be 0.5. And I'm going to go ahead and put this here. So I got 4 times 6, which is 24. And again, it's a whole number because it would be 24 over 1, because 1 times 1, my bottom number, is going to stay 1. So, and then again, anything over 1 is just going to be that same number, so identity property. So I'm going to use the same rules. I am going to look at my two numbers, half and negative 24, and negative 24 is the bigger one. It has more pull. So if you can imagine, like, you know, this one's a bigger dog, so it's pulling harder. So it's able to pull the answer into the negative. So 0.5 minus 24, just reverse it. 24 minus half is going to be 23.5. And again, don't forget that it's supposed to be a negative. And we would also have to put the function p of 18. So when we put in 18 into the function p, we get 23.5. And that should be the way that I should have wrote it, but oh well. All right, so that's it for that one. I'm going to move on to the next one. So we're going to be doing the same thing. We're going to be looking at our outputs and inputs in that order, actually, because I want you to think about this. So let's say that you have a microwave, right? And every day you cook ramen in it. And just for fun, you take it out when it's done and you put a thermometer in it. And it comes out to be the same degrees each time. All right, I don't know how hot that would actually be, but you know, you put a thermometer in it, you let the thermometer stop moving, and then you take it out and you look at it. And every single day you put it on for 2 minutes, which is what my microwave uses, cooks it nicely too. So if it was hotter, what does that mean? Does that mean it spent more or less time in the microwave? So if your noodles are hotter than usual, that means it probably spent more time in the microwave. If it's colder, then it probably spent less time in the microwave. So if you were to know how many degrees it changes for every like couple seconds that it stayed in there, you could work your way backwards and find out how much time was in there. So that's what we're doing with these ones here. We're working backwards. In this case here, I have f of 34, which is actually the output. That is the output, the result. So where I'm going to use this function here, and where I see f of x, I'm going to plug in 34. It's just like if it said y equals 34, you know, and y equals 3x plus 19. You just plug it in like that. Now again, in this case, we know the result, and we have to work backwards to know what was put into it. What is the input? So once it's plugged in, I'm going to minus 19 from both sides. And that's going to be 15 equals 3x. Divide both sides by 3. And I'm just going to use reflexive property so that the x goes first on the left side. 15 divided by 3 is 5. So there you go. Now if I plug 5 into this function, I should get 34, which, you know, I can check it really quick. 5 times 3 is 15. 15 plus 19 is 34. So that works out. So again, I'm kind of working backwards. I know we're used to putting inputs in and knowing what we get. But it's also kind of like if I told you, you know, you have $7.56 worth of hot and spicy McChickens, could you figure out how many sandwiches were bought? So if you know the price and you know how much the total was, can you tell how many sandwiches were bought? Yeah, you can do that. Just go back, just work it backwards. And that's exactly what you're doing in this case here. So I'm going to minus 19 on both of these. So 3x. My handwriting is just not there today. 1 and carry over. So it's going to be negative 81. And they're both negative. So remember, if they're both negative, they combine to make a bigger negative. And it cancels out. Now I have x by itself. And again, I'm just going to switch sides. So all I'm going to do is just switch the sides using reflexive property. And that's going to be negative 27. Now I know that because 3 times 30 is 90. And if I minus 9, that means I minus 3 from 30, so 27. And make sure your sign is the right sign. Make sure I didn't like leave a negative out or anything like that. Especially with the fraction ones, it's really easy to lose a negative when you have a lot of fraction bars and stuff like that, all rolling around together. Okay. So keeping on that idea of being able to work backwards, we're going to do some word problems where we have to work backwards or work forwards. So this guy, Owen, he pays a landscaping company $108 for an initial treatment. And then $74 per month after that. The function P of t equals 108 plus 74t represents the total amount of money he will have paid after the number of t months. So t is the number of months. So t is time in months. And p is probably payment, or how much he is paid. So on the first example here, we have one where we go forward. We are looking at P of 24. So remember T, we took out the T, which is months, and we put in 24. That means that this has been 24 months. So P of 24, and again, that's our input. And for this one here, I'm going to go ahead and use a calculator because I need to take out that T and replace it with 24. And that comes out to this. And now I have to add that. And I get this. So P of 24, so the function payment in 24 months is $1,884. That's the way you would read it. So now we have the input and the output. So again, Owen pays, well, let's see, Owen, pays, I guess we can just leave it like that, $1,884 for 24 months of lawn care. That's a lot of money to pay for lawn care. I mean, I never understood having a very fancy lawn, especially $2,000 worth of lawn. You know, with $2,000, he could have, I don't know, bought something better than that. But I don't know. Nobody here has nice lawns, so I guess it is what it is. You have to decide what's important for you. Okay, so now for the next one here, it says he has been receiving the lawn service. Oh, wait, no. How long has he been receiving the lawn service? If he has paid a total of $2,994 to date. So now we know how much it costed in total, but we don't know how long, because that's the question. It's asking how long. So we don't know that. So the time in months equals, but in this case here, actually, we don't need to know that. To get the time, we would have to plug it in like this. So with a total, so how much he's paid is going to be 108 plus 74 t. So again, the time is what we don't know. Now don't get confused and put the time as h of, or p of t. In this case, p of t is the payment over time, whereas t is just the time. Or that probably sounds more confusing. Usually if I'm going with a problem like this, I'll usually substitute the variable out. So like I might, instead of p of t, just say c or something like that. All right, so first thing I'm gonna do is ignore the initial setup. So 2994 minus 108, and we get and so if we take off the initial amount, because that initial amount was the only one that costs a different price, now we know that he paid $2,886 worth of months, because remember it's $74 a month, so if I divide that by 74, and I'm going to go ahead and switch sides here, so that's going to be 39 months. And before I even started this problem, I should have kind of done one of the strategies, and that is to estimate. Now, if it's almost $2,000 for 1 year, then this would be very close to 3 years. $3,000 would be very close to 3 years, and here it's 39 months, which is about 3 years and 3 months. So that makes sense. It's a little bit over 3 years worth of lawn care that he's got. And again, $3,000 for lawn care, no thank you. Just give me a garden hose from Home Depot and I'll take care of the rest. All right, now let's go ahead and go on to the last page of exercises. And these ones are a little bit different because you are going to have to be putting in multiple items into your function. So we have to use our functions f, which is negative 4x plus 9, and g of x, which is x squared minus 5 for these problems here. So I'm going to go ahead and plug in, so negative 4x, but I'm going to take out x. I'm going to leave a little bit of a bigger space, so 4x plus 9, but again, take out the x. And I'm going to drop in 4 times c plus 2. So there you go, put the c plus 2 in there. Now you have the whole thing. From here, you simplify just like you would an expression. So negative 4c. And don't forget, when you have a negative, you need to multiply this by a negative also. So that's going to be negative 4 times 2. So that's going to be negative 8. Negative 8 plus 9, so my positive number is bigger, so my result in the next step is going to be a positive. And now I just got to write it in function notation, so f of c plus 2 equals that. And we're done with that one. Ouch. Oopsie. And you would do the same with all of these, and I don't think I'm going to do all of them, maybe. I'm going to maybe skip 17 just in the interest of time. But I know 18 and 19 might be a little bit tougher, and definitely 20. So at first I thought 18 was going to be kind of tough, but it's actually not. And I'll show you what's going to go on with that one. So we're going to use the g function here. X squared minus 5. And again, I took out the x, so I can put in negative 4y to the third. Now, when you do this, when you have a power on a group, that means everything gets that power. So negative 4y to the third times negative 4y to the third. Now negative 4 times negative 4 is positive 16. Y to the 3 is y to the 6 minus 5. And I think that's it. I don't think there's anything else we can do after that because I don't have any more like terms and there's nothing else for me to multiply. I already squared the negative 4 and squared the y to the 3. So that's it. Like I said, that one is actually really not that tough. And again, number 19 is a little bit different because we're using a subtraction, but 17 and 19 are very similar. So if you can do 19, then you could probably do 17 fairly easily. But you know, sometimes things happen with these. So in this case here, I get a minus 3 because I'm going to drop it into here. But that x is squared. So I end up with something like that. Now, when you have a group that is squared, in this case, I have a binomial, which is 2 terms. I have a and negative 3. When that happens, I am going to have to expand it out and use my FOIL. So we've been using FOIL the past, you know, I think it was like the first 2 weeks of school. So I'll kind of touch on it lightly, but if you're not sure about that, you can always just go back and watch the other videos. So FOIL, remember, stands for first numbers. So in this case, I get a to the 2 power. Second step is a negative 3a because it's a times negative 3. Inside number is also going to be negative 3a because negative 3 times a is negative 3a. Negative times negative, so last numbers, fourth step. Last number is negative 3 times negative 3, which is positive 9. Now I'm going to clean this up, clean it up, put your numbers together. A squared minus 6a plus 6. Yeah, and you know, I've been kind of bad about boxing my answers lately. And when you box your answers, you can box the whole thing like that. But I guess this is good enough also. Now for this one here, I am going to need to move. I'm going to color code the thing. So I think I confused some of my morning classes this way because I ended up solving them both at the same time. So I'm going to try to avoid that this time. Now, I already know that in this case, 2m plus 1 is going to be squared. So to save some space, I'm going to go ahead and put 2m plus 1. And since it's squared as a group, just like the last one here, so you have a group squared, that means I'm going to put it into 2 parentheses. So x squared minus 5, so there you go, I squared x, and now I'm going to minus 5. Now I have to take care of my FOIL, so 2m times 2m. My first thing is first numbers. Outside numbers, 2m times 1 is 2m. 1 times 2m is also 2m. And last number is 1 times 1, which is 1 minus 5. Now I'm going to keep going till this entire first one is simplified. 4m squared plus 4m, and 1 minus 5 is negative 4. Okay, there we go. I got that whole first one. Now I'm going to make the second one in orange, so that's going to be the f of x. So I need my function f, so that's going to be negative 4x plus 9. And it's telling me instead of x, replace it with 3m minus 7. All right, so I'm going to have to take care of my parentheses first. So negative 4 times 3 is going to be negative 12m. And negative 4 times negative 7 is 28. All right, so the parenthesis is gone. We use our distributive property, so now we don't have a parenthesis anymore. Now I have negative 12m. And you know, I'm going to go ahead and combine these while I'm at it. So I get 37, I think. Now here's where things are a little bit tricky, because I know I get my questions from a few, like yesterday, last time I had a question similar to this one. I had some students asking, where did that negative come from? So there is going to be a negative right here. So what it's telling me is take the green function and minus the orange function. So I have to minus everything in that group. And by minusing it, that means I'm going to have to switch the signs on everything. So 4m squared plus 4m minus 4. And now I have to reverse the sign. So this is going to be plus 12m minus 37. All right, so combine your like terms. I have no other m square numbers. So that's the only m square number I have. I don't need to change anything else. Plus 16m and negative 4 and negative 37 is going to be negative 41. And that's going to be the final answer on that one. And there you go. I hope you enjoyed your shortened day, shortened lesson. Uh-oh, what's going on now? Shortened day, shortened lesson. So we have staff development today. But that's good though. We've been able to finish this lesson that we did not finish on Monday, and it fit perfectly into the time. So as always, that's it. We will go ahead and end the lesson here. I'll stand by if you have any more questions, you know, the usual stuff. But until then, if there's nothing else, see you tomorrow. Bye.